All right. Hello, everyone. Welcome back to the ClusterDuck stream. Today we're doing something a little bit different. Usually we during the streams we will be doing paired programming where we work on the current issues for the ClusterDuck protocol, the open source project. But today we're coming back to you about our most recent deployment in California called SpaceDucks. This is actually the second time we've done something like this. Oops. And yeah, so we're very excited to talk to you. I have Timo with me today. Wherever you are. Yeah, so to start off, what is SpaceDucks? So this came out of a collaborative effort with Cal Poly. We worked with two groups of Cal Poly students. One where we are working with their aerospace and weather balloon division, and then another we've been working for the Cal Poly capstone for building new duck devices, new hardware, and we wanted to test these out and put the two projects together. Now, what did we seek out to achieve? So for each mission, or I guess you could say we had three. We were putting duck devices into a payload that would be brought up into the edge of space using a weather balloon. And we did this to test our devices in extreme environments, so very high altitude. When you get very high, it also gets extremely cold. And then also when it's coming down, has a little parachute. It's still moving around very violently and very quickly, so we also wanted to see how our devices react in that environment. On the way up, we also had an opportunity to put on a bunch of sensors to get data for what's going on. And we also used a number of backhauls to record the data. So we had sending data over satellite. We also had a ground station that was recording messages that were sent over LoRa, but also we had used a spot tracker as something to help us make sure that we are able to recover the package. So here are some pictures of what we actually sent up in the sky. So you can see right here on the left is you can see the new hardware device. You can see this is built by the Quackheads. Quackheads are our Cal Poly group who have been working on the capstone to build this. Not only did they build a what we call the Quacker board, they also even built a little hat with extra sensors, especially for this mission, and which we found to work extremely well during the past week. Over here, you can see this is a Iridium satellite. You can see right here. This is where we're sending all of our data over satellite to the Iridium satellite, which then we can see on the cloud. Here you can see that outside of the device, we actually outside the payload, you can see here we have two arms which have cameras. We'll be putting out a video so you can see some really awesome footage from when it was up at the edge of space. We also have this really cool LED duck logo on the outside, which actually came in handy. And also you can see here, this is Josh. He was working a lot on the assembly. And also you can oversee here, this is Kevin Notberg, who worked a lot on building the Quacker board. Mm-hmm. Yeah, and something to about the installation and also the construction of the payload is that this is all 3D printed. So the layers for the cake are just like where I held everything together was 3D printed. The boxes were all 3D printed, and for the which surprisingly the when it got up there, we actually saw a difference for internal and external temperature of up to 30 degrees Celsius. So there's a difference. So when it was negative 20 degrees Celsius on the outside, it was 10 degrees Celsius on the inside, which is pretty crazy with our current setup, with just a little bit of insulation and also the devices running. So it was very impressive. Try talking. Oh, I don't know why it's. Let's see. Oh, sorry.
So,
Okay. Oh,
hey
well,
everyone.
all right. Do you want to talk
We're
about the payload again?
yes. Sorry, I was speaking for like 5 minutes, but
So I'm just
no
sitting
one
there
listened.
in silence, just like
Okay.
nodding my head and like, oh yeah, yeah,
Okay.
uh-huh.
Good. Um, okay. So I was talking about this whole payload and about the whole mission. I shared the quick story about in 2019, one of the Cal Poly students got in touch with Brian, which is one of our teammates. In 2019, they sent up the first duck to space, which was honestly a very simple payload with an Arduino Uno, just collecting sensor data. And we spent about 1.5 years working on building a SpaceDucks 2, which was this event. The whole goal was to get live communications with a duck up in the sky to low to the ground. Um, like Nick mentioned on the previous slide about the mission, we had a couple tasks for us, which was being able to operate these devices up in space is already the first thing. It will get around between -30 and 40 degrees Celsius up there, which is very cold. The other thing is being able to actually just build something that can get GPS data up the ground. Um, and one thing I shared as well is this is essentially just the same duck as any other duck. It has LoRa capabilities. It might have Wi-Fi. You can use Satcom or you can use LTE or any local data solution. It still, is a LoRa receiver and transmitter like any other duck. The difference about this one is, of course, it's a big box. It has insulation materials to keep it warm, and specifically this board is built by the Quack Hats, which is, of course, a custom built LoRa board. But we could have done this with a T-Beam or a Heltec, which we have done, just very different results because they were not as developed as this one. The crazy thing about this duck was it actually runs a custom firmware, I would say, because it is still a CDP. It's just ported to the Raspberry Pi Pico, which means
Yeah.
that it's not an ESP32 based board, but it's a whole different
Wait, it
architecture.
will. The ideas though they will all be running the same CDP. Um.
Yeah,
So
exactly. Um, and that code is also open source. It's still there. It's just this one had to be run a little bit differently to make sure all the components works. Um,
yeah. So
so
right
with
now it's a work in progress to port this over.
I think that progress is also being shared in our Slack. There's a specific channel for porting over the CDP to a C++ native code base instead of a specifically ESP32 or specifically a Pico. So you
Or
can
so,
follow the process
and
there.
yeah, and also moving away from relying on Arduino. So it's also direction we're going.
Yes. Um, and then the other thing, yeah, so this is actually, keep it short. This is the payload. It's essentially just a duck with a big battery and a GPS module and a Iridium satellite module. It has two cameras, but it runs the
Well,
CDP, just a different version of it.
yeah. So I mean, before you run off into the next part, yeah. So here are the other components. I don't know. Do we have a picture? I don't think we have a picture in here where we can see the original board, but this Le Fourier is a hat that goes on top of the Quacker board that was built. And on here are so a couple other sensors, which is I believe is a BMP 388 and the BMX 160, which gave us the temperature, pressure, an altimeter, so we could see what was we had one on the inside and one on the outside, so we were able to see the temperature and pressure on the inside and on the outside, also as well as track how high we were. This was also very important for us when we were watching as the balloon went up to see how high it was, and that helped us calculate. Okay, it's going to around this height, it's going to pop, and then also we could calculate its rate of descent as it's coming down. We also had the BMX 160 helped us track what the acceleration was. So it was actually very interesting to see when the balloon would pop. You would see all of a sudden that there's a change in acceleration, or also how as it's going up, seeing that it's still climbing. As Timo said, we did have a multitude of cameras on there to film the voyage. And then also we had GPS, which was instrumental for when it comes down, that we can find it and recover all the devices. So, so we have here a picture. So this is it's a little bit small, but this is the board that was developed. It doesn't have all the components on it, but this is kind of what it looks like underneath that hat, which would go over this part right here. And this is the TTGO that we would normally use with the CDP. And per a payload, per a box, would have one of each of these, and we would be sending all of this sensor data. And we would send this data over two different ways. So we had one way is where we're sending it over the rock block, which is sending it over the Iridium satellite network, and then also over LoRa. And it was actually extremely impressive to see that when we were streaming over LoRa, that we were actually able to receive transmissions the whole way, even though the payloads were going upwards of 25 kilometers into the sky. The longest link we were actually able to capture was over 50 kilometers away. So normally with the TTGO on the ground, you would maybe get 1 to 2 kilometers. But with the balloon up in the sky with the Quacker board, we were able to get much longer distance. So launch day. So you can see here where Jack is filling up the balloon with... is it helium or hydrogen? I keep on forgetting. I think it's
Helium.
helium.
Yeah.
Okay, yeah, helium. So he's sitting on on the tank right there. So he was filling it up, and right now he's checking how much lift the balloon is generating, which is really important for when we run our prediction models to see where it lands. So when these things go up way up in the sky, they land, over very far away when the wind takes them. So it's very important for us to be able to take accurate measurements so that when we predict, we can predict very accurately. Over here, we can see this is our ground team working on with our the Yagi antenna. This is what we use to connect to the over LoRa, and this is where the device we actually use to close the 50-kilometer LoRa link. And actually, it was something that was very interesting that we found during this process was that LoRa was actually one of the most stable connections that we had during this whole process. We would lose packets here and there with Iridium, especially due to the movement of the payload as it's going up. It's not very smooth sometimes, so you might not have proper alignment of the antennas. But the whole way we were able to, as long as we were pointing it in the right direction, we were able to get LoRa packets.
And that's one of I think the most amazing things from last week. You probably have seen LoRa WAN connections going over hundreds of kilometers maybe, with the very expensive and big end nodes that are receivers. I think what is true to our system is we still use two ducks, just a different antenna, same output power, and we're able to get 50 kilometers of range, which if you know LoRa, that's actually not very easy to get. We were very surprised to see we're getting live data feed of LoRa from 100,000 feet up to the sky into our duck, which is still a super small piece of electronics, just a big antenna. For a very cost-effective solution, and I think this will help us in our future of disaster relief and connecting places together is being able to set up this network so quickly and being able to tug over 50 kilometers with a small effort of LoRa. I mean, the effort of building the ducks and the spacing was very big, but I think the kind of like the project itself was kind of, I was surprised by the connection we were able to get, and I think that's one of the big things I want to share with you is um, the our how we actually were able to get this. And you see in the middle picture, there's the people in the car. They were getting live data packets from LoRa. They can predict, use that data to predict their landing zone, and that's how we drove off to a landing zone. And we're able to recover some of the payloads that we sent up in the sky.
Mm-hmm. Yeah, so here's some more pictures you can see. So on our last day, we actually launched 2 of these weather balloons. And so here, oh, he's jumping. So you can see on the right, you can actually see a picture of Phoenix 1 taking a nice little selfie with the Earth. And also you can, so maybe something to point out here in this picture. So right here is where we have our BMP 388, where it's the temperature and pressure. Up here is our Iridium antenna. Right here we have another antenna that's for the T-beam. And the Quacker board antenna, you can't see it underneath on the bottom. There's a patch antenna on the bottom. And then our GPS antenna is also on top of here, which you can't see. So here's some more pictures of what it looks like when we're launching. So you can see here is the balloon is tied to a string, and then right here is our parachute, which is very important because it helps slow down the descent so it doesn't just fall to the ground. So you can also see right over here with the antenna, it's pointing right at the balloon that's up there in the sky. And this is also what we were seeing live during the deployment, where we're able to see the data here. So you can have like a message counter and all different kinds of data along here. We'll be putting a report out, and where you can actually see. We'll be releasing all the data that we took during this deployment, as well as also what our findings were.
Yeah, and we'll also be able, and hopefully in a couple of weeks, we'll be able to provide data sets from the flight, where you can, we can help us with the simulations, or we can do any kind of data analytics on top of our findings. I think we did capture RSSI on some of the payloads. It could be very interesting to see how that operated, and it will very much help us to improve the CDP to leverage like other features and settings in different kinds of environments like this.
Yeah, so here, actually speaking of data, here is actually how we structured our data. And so this, like I said, we will be releasing all this data online. So if anyone wants to look at it or do what they want with it, they'll be able to.
And I think I added this slide in here to show everyone the CDP is still the same protocol. You're able to take any reading, add it to a packet, and that packet can travel over our LoRa mesh. And I think that's kind of like the gist of everything is we have like 6 different sensors, 20 different readings. It's about 100 bytes of data. The one thing we did was we took different examples that are in the CDP for different sensors. We took the data, we added it to the same packet, and we sent it off over LoRa. And we did not have to worry about the setup of the ducks or how the data format looks, because as long as you can add data to a packet, you can use the CDP to transfer any data you want. You are limited by a current size, but you can see we're getting 9 different sensor readings at once over one LoRa packet, and by that packet we were able to know where the duck is, what its speed was, what angle it was, what the temperature, the pressure, everything we need to know live. We were able to send over one LoRa packet through the sky. So, if you maybe are new here and you're like, what is the CDP? you can always go like online and use any kinds of sensor you want to send data over your own LoRa mesh network. In this scenario, we hooked up 9 different sensors, and you can also just use text or anything else. So it's kind of a quick reminder that I think, you're not limited by any CDP work we have done or is done by the open source community. You can leverage this for a lot of different scenarios. So I think that's a good thing to always mention to everyone, that there's different ways you can leverage the CDP in your own scenario.
Oh, yeah, we'll be putting the data sets out soon. Yeah, so just a real quick recap. We were able to get which was one of the biggest surprises, was how reliable the LoRa link was. We were able to get when we were collecting data, when we had the antenna up, we didn't miss a single packet, and we were able to achieve for Project Owl our longest break our personal record for longest link for 50 kilometers from ground to air, which is incredible. At that point you couldn't even see the balloon anymore. It was so far away. Also, we were able to get the live telemetry from over 100,000 feet in the sky. And then also something that was a bit of a surprise, which we didn't really, wasn't one of our original goals, but we actually saw when we put two payloads up at the same time, they were actually sending data between each other and hopping. Which was pretty cool to see from the ground station. Yeah, and so that's it. I don't know if Timo, you want to add anything, or if there's anyone.
No, I think
Any
this
questions in the
is
stream?
a little bit shorter. I think maybe the important thing is we're going to go back to our CDP developments starting today. We'll have a lot of different projects we're working on in the CDP. It has to do with MQTT. We're still working on figuring out packet linking up and over LoRa. So it was a shorter stream, but we wanted to share kind of our exciting stuff that helped us get a lot of new knowledge for the ClusterDuck protocol. I think everybody that wants to know more about this, please feel free to reach out. We're able to provide data sets. We're trying to build a full report that shows how this payload was put together, what you need to build your own potentially. And if you want to contribute to something like this, they're all part of the CDP community. So everyone that was involved in this project is in Slack as well. So there's enough.
Look forward to the report, and also there will be a video where you'll get to see more of the heroes who made this all possible. So look forward to that. It should hopefully come in the next coming week or so, along with those reports and data sets.
Sounds great. Yeah, this was a little bit shorter, but I think we covered that. The CDP is awesome. Being able to communicate LoRa over 100,000 feet, hopping between ducks over 0.1 watts is fascinating. And I think this only opens up a new world for us to do more testing in extreme environments and hopefully implement in more natural disaster areas, proving that our technology has actually a solution here.
Yeah, no, it was also on top of it. It was done with extreme low power. So it was we even measured the batteries, and it's just barely used any power for the whole flight. So it was very, very exciting trip. More information and pictures will be coming out. So stay tuned. Check out our Slack, where we'll be posting the most up-to-date news, and tune in next week where we'll be returning to our regular paired programming on the CDP.
Thank you, Nick, and thanks everyone for watching.
All right.
We'll be there.
All right. Thank you.
Awesome.
Have a good one.